Alrighty, here we go. And continuing on in the second part of Mod 3 Lesson 2 here. You've talked about rate of change, and now we're going to work on slope and what that means specifically. So, you've heard this mention of the word slope before, and I just want to reiterate what it means. And it's really this, that it is a measurement. It's a number, and it specifically measures the steepness of a line. Okay, so we assign it a number value. Usually we write it as a ratio. Okay, so when I say ratio, I'm comparing two numbers, and we often write that as a fraction. So it actually is exactly the same as the rate of change that we were just doing yesterday. So as we kind of put all this together, it's a number. It's usually written as a ratio or a fraction. It measures how steep the line is. Okay, so what we've done so far is we've been looking at data in a table and kind of measuring interval to interval from here to here, figure out the change in the y value over the change in the x value. I tend to be one who likes to write it this way, as using the Greek letter delta, change in the y over change in the x. Okay, sometimes you'll see this described as the change in the dependent variable. I'm going to abbreviate variable over the change in the independent variable. Okay, variable. There we go. If you've dealt with slope much at all, this also is often written as the rise over the run. Okay, I tend to like to think of it as this way, just because sometimes the word rise kind of makes you think like it always has to be positive, and it's not true. It's really just the change in the vertical over the change in the horizontal. So there's lots of ways that you can envision and picture what slope is. But our goal is to get you to recognize that you can get it from a table. You can calculate it from a graph by picking 2 points and then measuring in a sense that way. And then you can also get it from just giving ordered pairs and determining it algebraically that way. So let's take a look at some examples and it'll start to become a lot more clear. All right. So I want you to get out a coordinate system. If you need to take out just some plain old notebook paper and quick make an XY axis here, and then get some intervals plotted in there. Or if you'd prefer, you could also put it, you can put these, if you have a whiteboard, if we're in the classroom watching this, you could put it on the back side of the whiteboard. And I want you to plot these 2 points on here. Let's choose something like 1, 7, and let's say something like -4, 3, or something like that. Okay, so I'll get those plotted in there. Graph, here's 1, 7, here's -4, 3. All right, and then go ahead and sketch a line segment. Okay, you can even extend beyond those. Now, let's take a look at this here. All right, what I want you to do is calculate the change in the horizontal values and vertical values, and I want you then to write this ratio or this fraction. So up here, I'm going to write change in y over change in x, or if you prefer thinking of it as rise over run. Okay, so here we go. If I start here and I travel here, basically it's kind of like you have to get to that other location and you can only travel on vertical and horizontal roads. So if I'm starting here, I'm going to start thinking, well, I have to come up this far. Okay, so I was at a level of 3, and now I'm at a level of 7. I had to go up 4 units. That's your rise. That's the change in the Y value. Now, horizontally, you're going to travel this way to the right. When you travel to the right, that's also positive. So 1, 2, 3, 4, 5 units. And that's your slope. It's a number. It's comparing these two. It's 4/5, which is about 0.8 tenths. Okay. All right. So, and notice that that's a positive value. Okay. Now, what if, just to be difficult, what if I didn't want to travel, let's say, from, I'm going to change color here, just a sec. What if I didn't want to start from here and work up? What if I started at this point and traveled back down to that one? Well, you do the same thing, except this time my rise or my vertical change is negative. So my rise would have been -4. The run, I travel from here and head to the left. When you head to the left horizontally, that's a negative value, -5. That was the run. Now, take a look here. -4 over -5, simplified. That ends up being exactly 4/5 again. So it really doesn't matter from which point you start at and to travel to the other one. You're going to get the same end value. Okay, so whether you start from this one and go up or start from this one and travel downward, you're still going to get the same measurement that describes the slope of that line. All right, let's try another one. How about this? -2, 5, excuse me, -2, 5. So just, let's get that plotted. And let's do something like 1, 1. Just something pretty simple right there. Okay? Connect these guys. All right. I want to find the slope of this line. The slope is equal to the change in the y value or the change in the x value. Or you could think of it as rise over run. Now, let's see what you come up with here. Okay, if I start at this point, I'm going to go down first. Let's say I had to go down 1, 2, 3, 4, because I went from a level 5 to a level of 1. Okay, 5 take away 1, that's 4. Oh, but it went downward, which means I have to write that as -4. All right, now my run is traveling to the right. That's positive. And count your spots. 1, 2, 3. I'd say that my value of my slope is -4/3. What if you traveled the other way? What if I started here at this one? Find your vertical change. I would have to go up 1, 2, 3, up 4. Then I have to go to the left 3. So I'd have +4 over -3. And guess what? It's the same thing. Same thing. Let's look at another one. Oh, let's say something like -4, 2, and 5, 2. Connect the dots here so we see the line segment that we're measuring. All right, your job is to figure out, what's the rise over the run? What's my vertical change over my horizontal change? Well, to get from here to here, I'm not changing vertically. I don't have any movement in the vertical axis. How about horizontally? Oh yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9. Or if you started at this point, okay, and then you were going to travel this way to get to that one, your rise is still 0. I didn't change vertically, but you were going to the left this time, just negative 9. Negative 9. Well, what's 0 over 9? That's just 0. What's 0 over negative 9? 0. This slope is 0. Tuck that away as an important one to remember. Anything horizontal, slope is 0. All right, last but not least here, let's do something like 4, 3. So, 3. And let's do something like negative 2. Nope, take that back. 4, negative 2. 1, 2, 3, 4. Down to right there. Connect these guys. Again, to find the slope of this line segment, you have to find the rise over the run, the change in your y value over the change in your x value. So, if I start here at this point, my rise is actually 1, 2, 3, 4, 5, 6. Wait, where was I? This one? 1, 2, 3, 4, 5. Okay, and in this case it was negative. What is your run? My run, how much did I change horizontally? 0. If you started at the bottom one instead and went up, how would it look different? Well, this time my rise is positive 5. My run is still 0. What on earth are these values equal to? Negative 5 over 0, 5 over 0. If you try doing that on a calculator, it gives you an error message. I think it usually says something like divide by 0 error. That's because we can't. Our real numbers don't allow for division by 0. So, impossible, undefined. Can't find the slope of that. Okay, so we've gone through a couple examples here, and I need you to get a general picture in mind. Positive slopes tend or actually slant upward. Negative slopes slant downward. A 0 slope is exactly horizontal, and an undefined slope is completely vertical. Okay? Keep that in mind. Positive, negative, 0, undefined, impossible. All right, now putting it all together then, what I want you to do is turn to page 79 in your textbook, pause the video if you need to. Basically, we want to work our way into coming up with an algebraic way, like an equation or a formula you can use to calculate slope. So they put it right here, okay? Remember how we defined it? We said that slope is the change in the y values over the change in the x values, okay? When I have two different points or ordered pairs, what I have to do is say, all right, well, here's one of my x and y values or coordinates. We'll call this point 1. And then I have another one, x and y. We'll call that point 2. However, here's an issue. How do I tell the difference between these guys? So what they do is they say, well, since this is the first point, we'll call this x1 and y1. Here's the second point. We'll call this x2 and y2. All right. If you want to find the slope, you need to find the change in the y values That means take your two y values and take the difference. Subtract them, okay? Then do the same thing with your x coordinates or your x values. Subtract them, find the difference. Just make sure if you choose to start with this point, you start with both the y and the x coordinates, okay? So let's look at this example. Here's 2 points, -3, 2, -6, 4, okay? If you went and graphed it, -3, 2 is right here, and -6, 4 is right there. The first thing I want you to notice is before you even start calculating, you're like, man, this thing's going downward. That means it's got to have a negative slope. Let's see how much. If I start here, I'm going to have to go down 2 and then to the right 3. If you started at this one, my rise would be +2, but my run would be -3. Regardless, these are all equal to each other, so it doesn't matter. You're all good, okay? It's all good. Slope is -2/3. Let's take a look at number 4 here for your turn. Here you have a graph. It's showing the rate at which water is leaking out of some kind of tank. And so the slope of the line will give you this information. The rate at which the leaking in gallons per minute is occurring out of this tank. Find the slope. So take a look at this picture down here. Zoom, move this up a little. All right, here's a point. This is at an x value of 4 and a y value of 3. Here, this one appears to be where x is 8. X is 8 and y is 6. Okay, so now I need you to think that slope is always the change in y over the change in x. So get your two y coordinates, 3 and 6. You decide right now, since I have to find the difference, do you want to go 3 minus 6 or 6 minus 3? I don't care. I don't like negatives traditionally, so I'm going to pick 6 over 3. That means you started with this one, subtracted that one. Oh, let's see. So then when we do the x coordinate, that means you have to start with this one, the 8 minus the 4. Okay? That should be a 4. I'm saying it should be 3/4. Check it out by drawing on a picture. You went up 1, 2, up 3, over 1, 2, 3, 4. The rise is 3. The run is 4. The slope is 3/4. Cool. So this is what you're going to be looking at for today. All right? So what I want you to do, we've already done some of this, okay? But I want you to basically, picking up where we left off, go through and do the rest of the assignment. Alrighty? Good luck. And as always, may the force be with you.